Welcome to Physics 2212 Lab 2. In this lab, we are calculating the forces between two charged pieces of tape. Using math and a computational model, we can figure out the value of this charge between the two pieces of tape. Some important concepts include electric fields and forces, Newton's second law, and Coulomb's law. We are assuming both pieces of tape are the same length and charge, and that only Fe and Fg are acting on the system. We are not treating each tape as a point charge, and we are assuming we didn't lose or transfer any charge while we are handling the tape during the experiment. We are also not taking air resistance into account, as there is no movement of the tape, so air resistance won't have an effect on it. In Lab 1, we used code and treated both pieces of tape as a point charge. We attempted to balance with the force of gravity. We got a Q charge that was equal to 1.04403 e to the negative 8 power. In Lab 2, instead of treating our tape as a point charge, we are taking the value of the charge across the entire piece of tape. To do this, we are going to use new code. To start out, we define our physical constants like mass, length, and distance, and then our gravity and K value. Next, we use our function from Lab 1 to calculate the charge of the electric field. Next, we create a line charge using the function given to us in our code. After that, we create two line charges in order to represent the top and bottom tape. Next, we calculate the force of the electric field on the top tape due to the bottom tape. Essentially, we're doing the calculation a large number of times across a large number of sections across the tape to create a more accurate calculation of the force of the electric field. Lastly, we create arrows for the electric force and gravitational force to represent them so we can see them in the viewfinder. So what were our so what were our results? Our Q from lab 1 was 1.04403 e to the negative 8. Our Q from lab 2 was 2.102 e to the negative 8. Our difference was roughly 100%. Model 2 is obviously significantly more accurate as it considers the charge over the curvature of the tape instead of just a single point. Some sources of error could include improper tape handling during the initial experiment, incorrect math, and we didn't divide charge between an infinite section of tape. What if we had modeled each of our tapes as a single point charge, like in the previous lab? The results would have been off again, likely too low, as it is not as accurate of a computation. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? The estimates differ because the point charge makes a lot of assumptions about the shape and size of the object. Our second model, using the line charge, calculates the value of the charge across a large number of sections across the piece of tape. This results in a more accurate and closer to real value. In conclusion, we can see that the second model used in this lab is more accurate due to the more accurate form of calculation. Further accuracy could be obtained by increasing the number of sections used in our calculation.